Welcome to TCW Technologies. My name is Bob Newman, and I'm here today to share with you some important information about our integrated backup battery system. The IBBS system, or integrated backup battery system, is a self-contained source of backup power used for avionics on small aircraft. We developed the IBBS system in 2010, and it has been widely accepted in the experimental aircraft market, where it's used with many of the EFIS systems, navigators, and electronics such as engine monitors that are found on these aircraft. There was a requirement in the marketplace to add secondary power for these aircraft that very often originally were not designed with two sources of power. As the aircraft requirements for electronics increased, the need for a secondary source of power became very important. We provided that system in a fully engineered solution, and we brought out the IBBS system in 2010. Since then, we've provided more than 10,000 units out into the field. Around 2014, we started really getting a lot of requests from the field to increase our product to not only do experimental aircraft, but also to be available for the certified market. We answered that need with our IBBS system that carries a TSO approval, and at current, all of our models are TSO approved to C179B. We have models for both 12 volt and 24 volt applications. Our 12 volt applications include a 3 amp hour and a 6 amp hour product, and then in 24 volts we have a 3 amp hour product. All of our designs are built on the same platform, and we've got a very good service record with these devices. Our backup battery system is meant to be wired directly to particular avionics in the airplane. It does not back up the entire aircraft, but instead backs up particular avionics that are on the airplane. For example, very often our backup batteries are connected to EFIS systems or navigators, transponders, ADS-B modules, and engine monitor modules. These monitor modules are very important because many of the aircraft today, the only way to see important engine information is to have these systems up and running during engine starting. And our product provides a source of steady power for those avionics during engine cranking. Now, the IBBS system is a custom system that we built, and it's completely self-contained. So the control electronics and the battery are all housed within one enclosure. Our system is electrically connected to the ship's bus, our main aircraft power supply, and our system is constantly monitoring the aircraft's power supply to see if anything is going wrong. So for example, in our 12 volt models, we're constantly monitoring to see whether the bus falls below 11 volts. In our 24 volt models, we're constantly monitoring to see if the bus falls below 22 volts. If we detect that condition, our backup battery turns on and provides continuous uninterrupted power to the connected avionics. Further, our system includes a very sophisticated charge controller for taking care of monitoring and charging the backup battery. So let's take a look at what's inside of an IBBS system. So first of all, the IBBS system is housed in a custom metal enclosure. This aluminum enclosure is folded and welded in the corners for structural integrity. The equipment goes inside the unit, and then a base plate goes on the bottom of the unit and then is held with 6 screws around the perimeter. Inside every IBBS unit is the control electronics. So we have a custom circuit that we've developed for this application. This system does a variety of things. First of all, as I mentioned, it monitors and it's constantly checking the aircraft bus to see if it's within specifications. If it falls out of specs, then the control electronics in here turn on and take backup battery voltage and apply it to the connected LRUs. And then additionally, of course, if the power supply on the main ship comes back up, it takes the backup battery offline. The next thing that our system does is it constantly is monitoring and checking the battery, the internal backup battery. So we have a charge controller system that's built with all with hardware. There's no software involved, and this system constantly is monitoring the health of the backup battery. When it determines that it's appropriate and safe, it can charge the backup battery. Now our system is not a passive system. It doesn't just merely connect the backup battery to the ship's voltage for charging. Instead, it goes through a separate DC to DC converter that takes input power from the ship and conditions it and applies it to the backup battery as needed. Now, our system also is monitoring all the cells within the battery, not just the battery pack. So every cell is checked for voltage and confirmed that it's in a proper state for receiving charge. It also does charge balancing as well. Now we do what's called conditioned or acceptance-based charging. So only when the battery needs to charge does it charge, and it has to be within particular operating parameters. For example, the battery can't be over discharged, and also we prevent it from being overcharged. We also deliver a very precise amount of current and ensure that it's operating correctly. Our control system additionally monitors the temperature. In every battery pack, there's a thermocouple for measuring the battery temperature. So we qualify the charging based on voltage, both high and low, as well as temperature, and as well as total pack voltage and state of charge. So the control circuit is very sophisticated and is constantly monitoring the battery. Additionally, if it sees out of specification limits, it can completely disconnect the battery from the control circuitry and isolate it from the system. Lastly, we have diode protection to prevent backflow. So our battery cannot backflow into the main aircraft bus, and also if voltage was inadvertently connected to the outputs of our device, it cannot backflow into our battery as well. So our control system is entirely built on this system, and it is specifically designed for controlling and operating our lithium iron phosphate battery. Lastly is our battery. Our battery pack is a custom battery that's built for us. It's a 12 volt 3 amp hour battery pack. It's 4 cells in series, again with the lithium iron phosphate chemistry. The battery cells are welded together, there's a thermocouple installed, and then all of our cell voltages are terminated out to our header. The wires are silicon jacketed wire for high temperature applications. Lastly, our control circuit board, you'll notice these orange bumpers here. These are silicon bumpers, again high temperature material, and they stand the battery off of the circuit board for a complete air gap off of the circuit board. So none of the electronic components or the circuit board actually come in contact with the battery. Now we use one of these battery packs for our smaller units, and then our larger units use 2 of the identical battery packs. They're wired together on headers on the circuit board and connected appropriately in series or parallel depending on the required voltage. The system is constructed by installing our circuit board into our metal housing, and it's fastened down with 4 screws. Then the appropriate number of batteries are added, and they're connected to the wire headers in the circuit board. When they're properly connected up, the 1 or 2 batteries as appropriate fit inside the enclosure. The enclosure is sealed and screws are placed around the perimeter. Then the unit goes to final test to confirm all of its operating functions are operating as designed. So that's the IBBS system from TCW Technologies. Thank you.